Now that we know what data types can be used in Hive, let's look at an example of a simple Hive table being created with HQL. In this example, a table named Users is being created with 4 columns. There is an ID column, which is of the int data type, along with an Office ID column of the same type. There also is a name column that is of the string data type, and finally an array column called Children, which can hold string values. We tell Hive that the fields in our rows are delimited by the pipe character. We then tell Hive that the collection items in the array field are terminated by the colon character. Finally, we explicitly specify that our data file is a plain text file. Once our table is created, we can then run the show tables statement to see a listing of all the tables in our database. We can also use the describe statement to view some metadata for a specific table. Further, we can use describe extended to view additional table metadata. In this example, our new users table will now be partitioned on division, which we specify as of the string data type. We accomplish this by adding the partition by clause. Division will now be a virtual column. The division is not actually stored in the data file with the rest of the data. Now that we have a partition table, once data is loaded in, our Hive queries will be able to take advantage of the fact that each partition is a separate directory that contains just that one partition's data on the file system. This will help us achieve better performance, especially when running queries with where clauses. The less data we need to read and process for a given query, the better, as we gain the benefit of reduced latency. Inside the box on this screen, you can get a feel for what the physical directory structure would look like for a table with 3 partitions. Down the warehouse path, we can see the directory for the database, the table, and the partition. Tables in Hive can either be managed or external. Tables by default are managed by Hive. Hive controls the metadata for that table and the lifecycle of the actual data in the table. The managed table data is stored in subdirectories within the configured warehouse directory. Dropping a managed table will delete the actual table data in addition to the metadata Hive stored for that table. Let's contrast that behavior to Hive's external tables. An external table's data files are stored in a location outside of Hive. Hive does not assume it owns the data in the table. Dropping an external table deletes just the table metadata and leaves the actual data untouched. External tables can be useful if you are sharing your data with other tools outside of Hive. Creating an external table simply requires the addition of the external and location keywords in a create table statement. Dropping a table in Hive is done using the drop table syntax. There are a variety of ways to alter a Hive table. We can change the name of a table, add or remove columns, alter table properties, and more. In Hive, there's a variety of advanced topics, one of them being indexing. The goal of Hive indexing is to improve the speed of query lookups for certain columns of a table. It's important to note that the speed improvement comes at the cost of processing and disk space, as the index data is stored in another table on the file system. Here's a few simple statements that demonstrate how to create, show, and delete an index. There's also a variety of other indexing topics, including bitmap indexes and more. You have now completed this topic. Thank you for watching.